Okay, hi, I'm John Bartlett with Barricade Fire Gel, and we're making this brief little video. Hopefully it'll be brief little video for the Rosen Group today. It was a pleasure talking to you on the phone this morning. What we're going to do, just by way of explanation, we talked about some of the different ways that we might be able to mix it up and apply it for your unique needs with your industry. But we're going to show you just some samples today, and I hope it'll be instructive. And then after we mix it up and talk about that a little bit, we'll go onto the fire ground, we'll spray it, we'll put some fire to it, and take a look at it, even with some magnesium fires as we discussed. All right, again, this is the Barricade concentrate. It is a concentrate that's designed to be mixed with water. The range is anywhere, I think for your application, we'll find the range will be somewhere in between the 0.5 to probably 3 to 4, maybe 5% of the concentrate mixed with water. Once you get past the 3% range, you get a decreasing return on your investment, so to speak, because the gel at that point has soaked up all of the available water, and it just makes it thicker. But we'll use it in a fairly thin viscosity in one application, then we'll thicken it up and we'll make it a little bit thicker for use in a pressurized water extinguisher. And then if your needs dictate and you need it mixed up at its thickest, then that would be some sort of end-of-the-line eductor system, and we'll also show you and talk about that. But today we're going to make it real primitive and real basic. We're going to mix it by hand. We're going to show you how that works, and we've got the gallons marked out on the bucket here. We're going to fill this up to the 4-gallon mark, and then we're going to add in 150 cc's of the Barricade concentrate, and that'll give us our 1% mix. And then we'll double that. We'll add another 150 cc's to it for a total of about 3,000 cc's, and that'll give us our approximately 2% mix, as close as we can be here. So the best way to mix it, if you're actually doing it like this, if you're mixing it up by hand, so to speak, instead of using an eductor, the best way to mix it is to actually let the concentrate and the water go in together to provide the shear action, the mixing energy. So this is again our standard bucket. If you haven't used this container, if it's been sitting in storage for a while, you may notice some separation. Now this is of course right off the line here, so it's freshly made. But over time, as it sits, you may see a clear split of oil in the top part. That's why we went with these opaque containers, so it makes it easy to see that split. And all you have to do is several times a year, as you can see by the sticker here, several times a year, shake it up. Think of it like a bucket of paint as far as storage conditions. But this is all shook up, ready to go. You'll also notice that each container is sealed at the factory, and it's got a date stamp on it, so it tells us when this was manufactured. To use it, you open that up, take the cap off. Inside you'll find an inner liner. Remove that inner liner, and we're going to fill this up first to the 150 cc mark. Right about there, and you can see it looks like a creamy colored gel concentrate solution. Again, this is the we talked briefly on the phone this morning about the genesis of this project. In here are the same super absorbent polymers that I mentioned on the phone that are also found in baby diapers, and it was that fire that led to the development of this. If we're mixing it by hand, as I'm doing here today, the best thing to do is get your water flowing and pour it right into the mixing stream. Again, we're looking for a well-mixed solution, so this helps mix it up. And I'm going to stop here for a moment just to talk a little bit. Again, this chemical is very safe, but you can see that at this point we've got looks like just maybe a little over a gallon, almost 2 gallons in there. but you can see that it's causing the water to be thicker. And this, over time, as we mix this better, there's still some lumps in here, as you can see, but as this gets completely mixed up over a little bit of time, this will get thicker and thicker. But we're going to go ahead now and continue to add the water. But for your purposes, this may be all you need to do. You may just need to very primitively mix it up and go, yep, that's thick enough. Or you may want to be more exact and actually measure it out so you know exactly what your percentages are. The factors that are going to affect this, the viscosity, to a minor degree, the temperature of the water. In simple terms, the cooler the water, and by that I mean getting down near freezing, about 40 to 35 degrees Fahrenheit range, we start to see an effect on the hydration. So colder water will cause it to not be as thick at this point. And just the opposite is true also. If you use warmer water, you'll get the same thickness at higher temperature. You'll get the same performance, if you will, in terms of viscosity. It'll get thicker faster with warmer water, if that makes sense. So you also want to make sure you rinse all the residue out of the container. I'm going to fill it up now to the 4-gallon mark right here. Can't tell exactly, it looks like it's just about there. There we go. And now you can see that as I've added that water, it's become a little bit more thin. And again, this is what we call, it is a 1% solution. This is approximately 1% of our concentrate mixed in these 4 gallons of water. And this is an excellent solution at this viscosity for extinguishing purposes. Now obviously at this viscosity it doesn't do some of the things that it can do at higher viscosities and higher thicknesses. As an example, this wouldn't stick well to glass windows or vertical surfaces. We're concerned about that in wildland fires and protecting houses scenario. But for spraying it out of a pump-up sprayer, we talked about the application where the electric utility company would use it at this viscosity to go and extinguish fires on utility poles. This is the thickness, if you will, that we would use for that. So to make sure that it's entirely mixed at this point, you could even go above and beyond and maybe use a portable drill-powered stirring device such as this. You just want to make sure that it's well mixed up. Okay, and with that little bit of work, this is the solution ready to go. Now we'll pour this in to the pump-up sprayer, and then we'll make up twice the thickness. We'll make up a 2% solution, and we'll use that in the pressurized water extinguisher. So for this solution, you know, I always try to remember everything, but I had these out here for a reason. Obviously, for safety purposes, you probably should have on some safety glasses when you're doing this. But I also want you to be assured, we've developed this as firefighters, for firefighters, and this stuff is very safe. You can eat the stuff, you can get it on your skin, you can get it in your eyes. It's a very safe solution from that point of view. Everything in our formulation, besides the super absorbent polymers, which are found in baby diapers and therefore they have a long safety record of as a safe chemical, but all the other ingredients that go into this formulation are actually food grade. And for those reasons, we've won a whole bunch of environmental awards. It's been tested and approved for use by our U.S. Forest Service. What that means is, in simple terms, you can use this solution in the United States on any national parkland. We've also won awards from the EPA. It's the only fire chemical of any kind to have been awarded. It's called the EPA Champions Award, and EPA gave us this award for our environmentally friendly formulation using very safe surfactants in our formula. So, with that being said, I just want you to be assured that it is very safe, but it never hurts to wear your safety goggles. And we're going to pour this solution into this pump-up sprayer, which we'll use later. You can see what the solution looks like. Okay. We'll set that aside and we'll use that in a little bit with some live fire. And now we're going to mix up twice the percentage. Okay, on this solution now we're going to basically double what we did before. We're going to take this time 300 cc's. And we're going to mix that with the same 4 gallons of water in the same manner. Now let me just stop again, Ben, if you can kind of get a picture inside the bucket here. Now this is not even a gallon of water, but I just want you to see, as you stir this in, just how thick and how viscous of a solution you can make. And we can actually achieve this kind of thickness and spray it very successfully through some of our application systems, like the pressure washer system that we talked about this morning. But we're going to dilute this down again to about a 2% mix, simply by adding more water. And again, it's not complicated. You can easily control how thick or how thin the solution is just by adding more or less water to the solution. Again, I'm going to quickly fill it back up to the 4-gallon range and we'll stir it up. Alright, it looks like we're just about at the 4-gallon mark there. And again, we're going to use the portable drill-powered stirring device. And again, now this is a 2% solution, and you can see how much thicker that is than the 1%. We're going to dump this into our pressurized water extinguisher, and we'll spray it out using both of those devices. Okay, now we're going to pour this 2% solution into this pressurized water extinguisher. You can see I could have stirred it up a little better. There's still some lumps in there. We're going to fill it up to about the 2.5-gallon mark. Again, you can see I'm being pretty sloppy here, but cleanup is also pretty easy. Just hose off the residue. Close the top, and then with these extinguishers, if you're familiar with their use, you just use air to charge this up to 100 psi and it is ready for use. Obviously, if the need is there, which might be the case for you, this could also be charged with nitrogen as an example, which would also improve its fire protection capability. I'm going to go charge this up and then we'll go out onto the fire ground. Okay, so we're out here on our waterfront fire ground now, and we've taken some liberties here today. We took the liberty of taking this old propane tank, and we're calling this the equivalent of I think you refer to them as pigs, the machines. But we're going to use this just for some demonstration purposes here. I know it's a little bit smaller probably than the equipment, but hopefully it'll be instructive. I just want to first of all show what it looks like. Well, yeah, we'll show what it looks like coming out of the extinguisher here. This is the pressurized water extinguisher, again, the 2% solution. And I'm just going to take this and you can see that quite quickly and easily we're able to put a pretty thick, again this is 2%, pretty thick coating on here. And again, it may be instructive. Okay, sorry for the primitiveness of this film here today, but this is homemade just for you guys. What I want to do here is try to show you, hopefully, some of the fire protective capabilities. I'm going to actually take my hand and remove in a line here the Barricade gel from this side of the tank. And over here you can still see that we've got a pretty thick coating. And then I'm going to put a little fire to it. This is just a propane generated flame that we'll use here. And we'll just watch. By the way, if you get the chance to do something like this in your testing, which I'm sure you will, I would recommend at this stage, I don't have one here today, but I would recommend you get a thermal imaging camera like we carry on the fire engines, which show you not light and dark, but it shows you the difference between hot and cold. A thermal imaging camera with this little demonstration that I'm about to do would be very instructive, because you'd be able to see the actual temperatures difference between the sides, one that's coated and one that's not. Oh. Light up. Oh, by the way, I do want to say this tank is vented, obviously, with no danger of this thing bleviating or exploding here. Okay, again, it's going to be hot, but this side obviously is very hot over here. Something to think about in terms of how the chemical works. You can understand that there's still a coating of what is essentially 98% water over on this side, none over here. Understanding how that works, it's easy to understand that the surface under this coating cannot get any hotter than the boiling temperature of water, 212 degrees Fahrenheit or 100 degrees Celsius. The surface of the tank will not get any hotter than that 212 degrees until we've kept the heat on here long enough to boil all the water out of the solution, and then it would just leave the metal tank, and then of course the heat would increase and you'd have fire or burning. But right now, if you had a thermal imaging camera to confirm what I was telling you, you'd see that the surface of the tank on this side is still less than 212 degrees Fahrenheit. Temperature over on this side, I would suspect, is much higher than 212 degrees. Now, I also think, I'm trying to make this as reality-based as possible. I also think it's probably much more the norm for your situation that this pig, I think you call it, that's a great name, that this pig will be hot when it comes out of the pipe, when it comes out of the work after doing the work you're doing. So I'm going to go ahead and hold the torch on this side for a moment, and then we'll apply the gel again to the hot surface and let you see what happens there. And before I do that, I'll tell you what will happen. If it's above 212 degrees, which it will be, you'll see a period of time where as I hit it with the gel, it actually boils. The water, if you will, on the surface closest to the tank will actually boil. That'll cause the gel to slide off momentarily, but by cooling the tank very quickly, the gel will cool the tank down below 212 degrees Fahrenheit very quickly, and then you'll see that the gel will start to stick to it. So I'll tell you what it's going to do, and then we'll actually do it and see if it does what I told you it's going to do. All right, so I've gotten this side of the tank pretty hot now. I'm just going to hit it with the remainder of the gel over here, and you'll see what happens when the gel is applied to a hot metal surface. There you can see some of that boiling action taking place that I talked about. But this is obviously cooling the tank down much better than plain water would be doing. In order to achieve this effect with plain water, obviously you'd have to keep the water flowing in order to maintain the cooling effects. Here we're maintaining the cooling effects with just a one-time application. Again, maybe one of the most important considerations in this area is you don't have a lot of what may be contaminated water runoff to deal with by using this gel. That's another thing. But at some point, we'd have cooled that tank down sufficiently to where the gel coats, and even though it's still going to be very warm to my hand, you can see that, you know, it's well below 212 degrees now, which is well below the ignition temperatures of Class A combustibles and Class D fires also. So that's a 2% solution. That's how quickly and easily it can be applied. This is a 2.5 gallon standard pressurized water extinguisher. I still got, so I'll just go ahead and run this till it's empty just to give you an idea. Of course, you may choose to have a different nozzle on the end rather than my finger to divert the spray. And again, just to make the point, again, your personnel should be taking precautions, you know, to protect their skin, their eyes. But again, this stuff, it's very, very safe. I don't know how to do this other than this. You know, to let our potential customers and our customers know, because this really is not that far out of reality. It's very possible that our folks may get this on their skin, in their eyes, in their mouth. You know, hopefully they're in protective gear. But I just also, as a firefighter, it was very important. My dad worked on this before he passed away several years ago. My son, who's behind the camera, is now working on it with me. And as a family of firefighters, it was very important to us to make sure that this stuff is as extremely safe as it can. All right, now in this part of the demonstration, we're going to talk about extinguishing flammable metals. This is, as you can see, ground up magnesium, and just going to pour it out onto the ground here. This is aluminum that I'm pouring it onto, so obviously it's going to probably burn through the aluminum. I believe, if I'm not mistaken, magnesium burns at over 7,000 degrees Fahrenheit, so we'll have a pretty hot fire here. We'll get this magnesium burning here. Okay, we're going to get the magnesium burning. that the magnesium burning now, as any firefighter knows, but I'll demonstrate. You don't want to put water on a magnesium fire because it actually is burning hot enough. It breaks the water up into hydrogen and oxygen, and obviously it intensifies the fire. We're going to do the same thing now with some Barricade. Okay, now we're going to attack this fire using Barricade. I'm actually going to use our modified garden hose applicator here. It's small enough scale for the small scale magnesium fire. Now, when I first hit it with the Barricade, you'll see the same thing as when I put the water on. It's going to spark, it's going to cause the fire to intensify. But again, very quickly, the gel, or more specifically, the water that's trapped in the gel, will be able to remain on top, and I'll actually be able to cover this magnesium fire with a coating of gel to control and suppress it. Oh, here we go. Now I've got the gel coming out. Watch out, it will spark up. Now, as you can see, I'm actually able to put the gel over the top of the magnesium fire. It's building up on top. Now, at this point, the magnesium is still burning under the gel coating. You can still see some of it there, but watch, don't let it flare on you. There's much less heat. I could also use the gel to coat the exposures around this flammable metal fire. If this was a large-scale metal fire, you can understand how this technology is going to allow us to control and suppress these difficult types of fires better than any other choices that we have in the fire service. Just to make the point, the gel's been on there for a few seconds now. Just to make the point, I'm going to use just plain water again. We'll wash some of the gel off, and you'll see that that's still a very active hot fire under that gel. When I put the water to it and the oxygen gets back to it, this fire's going to re-flash. But I just want to point out that at this point it's a controlled fire. I can back my resources out. I can watch the fire. You can see that it's slowly deteriorating the gel surface on the top, but it's obviously a much more controlled situation than with any other choices that we have. And I'm just going to put some water to it. Be careful, Ben, it's going to spark up again. You can still see that we still have a, all right. Ben and I went running for the fences there for a second. But I just wanted to point out that we still have a very intense magnesium fire burning, but we're controlling it with the gel. And just to do it again, I'm going to hook back up to the gel, and we'll reapply the coating again. And again, now you can see that I'm back to that much more controlled magnesium fire situation. I hope this demonstration was instructive. Okay, we're still at this water magnesium fire. I also wanted to just quickly demonstrate. This was, again, remember the 1% solution that we put into the backpack sprayer. And again, I'm just trying to show you different ways that Barricade can be utilized. It can be pre-mixed, it can be put in a sprayer like this or a handheld sprayer. And you can see it'll also spray surfaces. And then one more shot over here. Here we are back at the propane tank, and again you can see that a device like this can be used to very quickly and easily put a coating on a surface like this. Again, this is a 1% solution. I don't know if you'll be able to see it clearly in the camera. Our light's starting to fade here in Florida, but you can see even at the 1% solution, there's a nice, relatively viscous coating that's on the tank, and it stays there. Again, once you understand the chemistry, I hope that there's no appearance of magic tricks or anything. It's not rocket science, it's fire science. It's not the Barricade that's keeping surfaces protected, that's keeping surfaces from burning. It's actually the water that the Barricade chemical can hold. It's just that through the magic of chemistry, so to speak, we can soak up and hold 700 to 1,000 times its weight in water with the Barricade concentrate. We can make it adhesive, we can stick it to surfaces, and we can just enhance, if you will, the well-known fire suppression and fire extinguishing effects of water. We just enhance those effects due to the characters of the chemistry, the increased viscosity, the adhesion, and it also breaks the water into fine individual units, if you will, which also gives us a quantum leap in terms of protection and suppression. So I hope this little video today was enlightening and informative. Sorry for the primitive nature of it, but we're looking forward to working with your group. I hope that this technology can help some of the challenges that you face in your industry. I'm looking forward to working with you. Again, thanks.